Hello students, welcome to our lesson for chapter 1.5. The title of this lesson is Rewriting Equations and Formulas. The TLOs for this section: I will solve literal equations by using properties of equality to rewrite equations and formulas. Alright, so everything that we've been doing has been leading up to this particular section, getting very used to using properties of equalities so that we can solve literal equations. Remember, we actually had this in our vocabulary when we did right before lesson 1.4. A literal equation is an equation that has two or more variables. We can rewrite equations using properties of equality to rearrange the variables to help us solve different equations. Let's say, for example, I have an array of circles and I want to know their circumference, but I wish to know their diameters. The formulas for circumference can be rearranged to help us find the answers more quickly. So given the circumference, find the diameter. The equation is circumference equals pi times diameter. If I want to solve for the diameter, I can simply use the division property of equality and divide through by pi. Pi over pi is 1 whole, and so you're left with the diameter isolated. On the other side, circumference divided by pi. So we have come up with a formula to find diameters knowing a circumference. So these two circles over here, the purple and blue circles, have circumferences of approximately 9.42 inches and 25.13 inches respectively. If I actually wanted to find the diameter, I could now make a substitution and approximate the diameter. Let me go ahead and use an approximation symbol. D is approximately equal to, and D is approximately equal to 25.13 over pi. And then from there, I could simply plug it in my calculator and find my solution. For fun, let's go ahead and grab our calculators. You can use your TI-83 calculators or just approximate pi as 3.14. Carry on your calculator. I'm going to go 9.42 divided by. Like I said, you could approximate pi as 3.14, but these calculators are nice. They have the pi symbol here, so I'll need to hit the second key and pi, hit enter. And so because diameters would probably want to round to the nearest whole, let's call this approximately 3 inches for the first one. And for the second one, I think I'd like to do that in blue actually, so it stands out a little better. And for the second circle, let me type 25.13. Divided by second. This button is pi. So let's round that to approximately 8 inches. And it was more convenient to solve for the diameter because I had more than one circle to solve for. That's why this skill is very nice to do, because if I'm doing research and I'm doing the same thing over and over and over again, I don't want to have to continually solve an equation. I'd rather just solve it once and then plug it in, get my immediate feedback. All right, so let's keep going with our applications. First, we're just going to practice the habit of rewriting. So solve the literal equation for y. I need to isolate the variable y. That means I'm looking for terms that are on the same side as y that need to go away. This x term needs to disappear, and so the property of equality that will make it disappear is the subtraction property of equality. By subtracting 4x from both sides, I will have negative 7y equals. I could write this in two ways. I could write this as 12 subtract 4x or negative 4x add 12. I'm going to go with negative 4x equal or plus 12 because that's slope-intercept form, and I'm very partial to slope-intercept form. So our y term is isolated, but the y variable has not been isolated yet. I'm going to get rid of the coefficient negative 7 through division, and I'll apply the division property of equality. Now you'll notice I'm not actually justifying my steps as I go. We've already assessed the standard for justifying our steps. If I wanted to add that to my notes as a level 4, I am definitely welcome to add that to my notes. For the purpose of these notes, we have enough new things and abstract concepts that I'm going to just perform the operations and tell you what I'm doing instead of writing it down. So now that we've divided through by -7, y has been isolated. -7 divided by -7 is +1. Coefficients of 1 we do not write. And then this one I'm going to separate my numerator and this is actually possible to do because of the distributive property. Dividing by -7 is the same thing as multiplying by -1/7. So this is what it was really looking like. I grouped my -4 out of 12, and instead of calling it dividing by -7, I can call it multiplying by -1/7. So by distributing it, it takes us to that step. I just don't have to show the step, so what I've drawn in red is an optional showing. And time to simplify. Y is isolated still. -4 over -7. Well, negative divided by negative is positive, but 4/7 doesn't reduce. I am going to write it as 4/7 x so that the x has that nice coefficient. And I don't have to rewrite 12 over -7 as a mixed number, but I am going to write it as subtract 12/7. And this would probably be the most appropriate way to write the solution. Now, one of the things with literal equations, you can have it in various forms. I could have gone from here and simply written it as y equals -4x add 12 over -7. This could have been my solution because y was already isolated. However, if I'm thinking of graphing, if I'm thinking of other operations I want to perform, the one that I've outlined in black is the simplest way to see the problem. It's the easiest way to graph it. I'll know what my intercept is, I know what my slope is. So this is preferred, but other answers like this one in blue would be accepted. All right, so y is isolated. We have our solution. I followed the steps of subtraction property of equality, division property of equality, and simplifying. All right, let's do another example. Solve the literal equation for w. So we have lots of variable terms. We have w, we have p, we have a. We're going to start treating variable terms that we're not focusing on the same way we would treat constant terms or other coefficients. So yes, this is a literal equation. It has lots of variables, but we still follow the same properties. So don't let that get you frustrated. I have w, and I want to isolate w. So in a situation where I have something like 2x add 5x equals, we'll do 14. Normally, if they have the same variable term, I can add the coefficients and call this 7x equals 14 and start solving from there. However, when one of the variable terms has a second variable term in it, we cannot combine them. What we can do, however, is what we call factoring out the common factor. X is a common factor. If I were to, say, factor it out of this expression, I'd be left with the coefficient 2 and the coefficient 5 and variable y for the second term. To show you how this works, if I were to use the distributive property, I'd have x times 2 plus x times 5y equals 14. Rearrange this to x and 5xy equals 14. So you can see that this step called factoring is the opposite of the distributive property. So factoring is the inverse of distributing. Is everyone okay with that? I hope so. If not, definitely send me an email question. So all of everything that I've written on the right is just related to what we're doing. I'm going to go ahead and erase this. That would be something that if you added to your notes could be like a level 4 material because you're giving extra information, you're giving background knowledge. But I'm going to come back to our original equation. W is common, so I'm going to pull it out. I'm going to have 3, the coefficient remaining. I'm going to have 4, the coefficient for the 4WP, and the variable P did not get factored out, equals A. W is now isolated from the quantity 3 add 4P. If I were to perform the distributive property, it would go back to where it was. So I am going to justify this because I do want to have that. We haven't factored yet this year, so factoring the variable W. All right, so back to an example that's simpler. If I have 8y equals 24, the way to get rid of the coefficient is using division because this means 8 multiplied by y or 8 groups of y. This means w times the quantity. So treat the quantity like a variable. If it was w times, well, let me not do that. Let's just do the quantity as it is. I want to isolate the variable. Over here, we got rid of the number by dividing by 8. Here, I'm going to get rid of what I want to disappear by dividing by the thing I want to disappear. So I want the group 3 add 4p to disappear. Using the division property of equality, I do the same thing on both sides. So as in this example on the right, the 8's get solved for, and we have simplifying on the other side. So let me erase this example again. Let me cancel the things that are the same, top and bottom. The whole group 3 add 4p over 3 add 4p would become one whole, leaving me with variable w. On the other side, we have something that can't really be simplified, so we actually write it exactly the way we see it. The solution is w equals a over 3 add 4p. Since I justified one step, let me justify this other. Division property of equality. All right. See if there's anything else I can do. I think I'm going to just add my note back up there that factoring is the inverse of distributing. All right, let's keep going. The formula for the area of a circle is shown. Solve the formula for the radius, or r. So area equals pi times the radius squared, one that you hopefully have memorized. If not, I recommend it. So what we're going to say is, I know the area of a bunch of circles. I need to figure out all of their radii. So it would be simpler for me to know r equals, and then plug in the areas and just let the calculator do the work. In order to do that, first I need to get rid of the coefficient of pi. Before I do that, just a quick reminder, the order of operations, I have a memory tool called GEMS. So you're going to do the inverse of subtraction, but there isn't one. There's no addition either. There is multiplication and division. So I need to get rid of the coefficient pi. To do that, we'll divide by pi. So division property of equality. So area over pi is equal to a radius squared. The inverse operation of a square is to use the square root. So I'm going to take the square root, so the opposite of an exponent, inverse operations, of area over pi, the whole piece. When you solve the square root of a number squared, so let me take a perfect square like 36, that would be 6 squared, right? So if I did the square root of 6 squared, that would actually be 6 equals 6. Okay, so when I do the square root of r, it would be, sorry, square root of r squared, it would be r. Another thought. If I have a number squared, I could do, say, like 5. 5 times 5, which is what this means, equals 25. I want to remind you that when you square a term, when you use a negative value, you can also get the same answer. Negative 5 times negative 5 is also positive 25. So when you have a variable and you're taking the square root of it like we have over here with r, you actually have a positive solution such as 5 and a negative solution such as negative 5. So you're going to write your answer as plus or minus the square root of area over pi, because I can't simplify anything under the radical, which is another name for square root. But then I'm going to use logic. A radius is a measurement, and you cannot have a negative radius. So logic suggests that the negative solution doesn't exist because a radius is a distance. So because this is an application problem of an actual thing, a circle, for example. Actual physical circles, either you have a circle or you don't. So the radius could be 0, there's no circle, or the radius will be some positive number. So when you're doing variables with squares, you do have two answers normally. But again, the logic suggests that radius is distance, so only the positive answer exists. So that implies that there's only one solution. The radius is the positive square root of the area divided by pi. Okay, sorry, if the long pause was just for processing. If you have questions about this, this is more abstract lesson, so please make sure that you email me your questions. We're going to do one more example, and we're going to break this lesson into two parts. So example 4a and example 4b, and then we'll stop and do the second part of this lesson tomorrow. So example 4a says, a patio is in the shape of a parallelogram. I'm going to go ahead and underline that because that's important. Its base, which is up against the side of a house, is 13 feet. All right, I'm going to have to draw this because that's what I do. Let me get all the information first and we'll go from there. The area of the patio is 156 square feet. The height of the parallelogram, so I've got a base, let me underline base in blue, the word base. And then the height, let me do in red. So height of the parallelogram represents the distance. Now, so distance, positive answers, from the house to the edge of the patio. But they didn't tell us that. I'm probably going to need a variable. Probably. The yard is 24 yards deep from the house to the back of the fence. Oh, that's a lot of information. Yards deep. I'm going to have to draw a picture for sure. Okay, a patio is in the shape of a parallelogram. Remember, parallelograms just have to have one set of parallel lines. So a rectangle is actually a parallelogram. You could have a trapezoid that has a straight side, or you could have a more regular trapezoid. Actually, what am I thinking? No, trapezoids don't have... let me start over. parallelograms have two sets of parallel lines. Sorry about that. So a rectangle is an example of those. Trapezoids are not, though. I could have something like that. Okay, like a rhombus. So those are parallelograms. So one of those two things. Let me try to draw this according to what it says. So a patio is in the shape of a parallelogram. Its base is up against the side of a house. Okay, bird's eye view. All right, so I'm going to think of a house. And the base of the patio is against the edge of the house. So I'm going to call the blue base. That's my patio. Gave me the area of the patio. So it's hard to put areas on the pictures, so I'll just put it on the side. The height of the parallelogram represents the distance from the house to the edge of the patio. So I'm going to draw mine as a standard looking parallelogram. I don't know why anyone would want that, but maybe they have a strange shaped yard. The height distance from the edge of the patio from the house. So like that, H. The yard is 24 feet deep from the house to the back of a fence. Patio in the shape of, I gotta make sure I draw this right. The patio is in the shape of a parallelogram. Its base, which is up against the side of the house, is 13 feet. Oh, I should write that down. 13 feet. Okay. The height of the parallelogram represents the distance from the house to the edge of the patio and the yard. So the yard, I'm not really sure why we need this information, but apparently the yard is maybe some kind of rectangular shape. I don't really know. I give it some space on the back. From here to here is 24 yards. Not really sure why we need that information. Oh, I see why. Find the distance from the house to the, well, no, do I need that? I don't feel like I need that 24. Find the distance from the house to the edge of the patio. I don't think that 24 is needed. I think that's a distraction. That happens occasionally when we're doing problems, is they give you information that is meant to say, hey, do they know what they're doing? So this may be a distraction. Maybe we'll need it for the second part of this question. I can't remember. I'm going to reread just in case. Patio's in the shape of a parallelogram. Its base is 13 feet. Got that picture. The area of the patio, 156 square feet. Little arrow inside. Okay. The height of the parallelogram represents the distance from the house to the edge of the patio. I don't think I need anything about the yards. The 24 yards, I don't think I need that at all. Because the formula for area of a parallelogram is base times height. Just like a rectangle, base times height. Because a parallelogram is basically a slanting rectangle. All right, if I want to find the height, I'm going to solve this as a literal equation. I could make the substitutions now, but I don't want to. So let's divide by, we're solving for the height, so let's divide by the base. So to find the height of any parallelogram, simply take the area and divide it by the base. The distance from the house to the edge of the patio. Sweet. Okay, so for this first part, I bet we'll need that other number in the next part. I should have read it before I began, but that's okay. So the H equals 156 feet squared over 13 feet. All right, just by way of reminding you what happens with units of measure, 156 feet squared is feet by feet. and 13 feet. So when we're done, one set of feet cancels. So height isn't measured in square feet, height is just measured in feet. So the units of measure actually behave a lot like variables behave. All right, what is 156 divided by 13? I don't trust myself at the moment. I think I know the answer, but I'd rather just check it on my calculator. So we have 156 divided by 13. 12. Okay, yes, I would have got that right, but I felt like because I'm worried about that distractor, it was better to let my calculator do it. Okay, a little sentence here because this is an application problem. The height of the patio is 12 feet. Okay, I'm probably going to need that 24 yards for this next part. Let's see. Part B. Come on. How far is it from the edge of the patio to the back fence? Okay, so it wasn't a distractor. I was just the second part of the question. Let me grab my notes from the first part. Hold on. Okay, so I grabbed my picture because I wanted that, and we found that the height was 12 feet. Okay, so how far is it from the edge of the patio to the back fence? That is the distance here. So I'm going to call that X. So I'm going to say, this is something I'm going to do to practice for future. Let X be the distance from patio edge to back fence. Okay, so what I know is that the total distance from the house to the back fence is 24, and 24 would be the height of the patio plus X. And we have our, you know what, let's solve the literal equation. Let's subtract and solve for X. So 24 subtract the height of the patio will give me the distance from the patio to the fence. And we'll make our substitution 24 minus, not 12. 24 is yards and 12 is feet. So there are, in 1 yard, 3. Is that right? Hold on. I'm going to look that up. Yes, that's right. All right, so if I want to know how many yards this is, the height, I'm going to simply divide by 3, so it's 4 feet. So when I make my, 4 yards, when I make my substitutions, I better not use the number 12. I better use the number 4 and write it in yards. Or I need to write it all in feet. I just can't mix and match my measurements. So 24 minus 4 is 20. So X equals 20 yards. Let me make sure I didn't make any mistakes here. 24 yards. And then we had 12 feet, which is the same as 4 yards. 24 take away 4 yards, 20 yards. They have a big backyard. That's nice. Okay, little sentence here. It is 20 yards from patio to the back fence. So the other answer could be in feet. So I simply do 20 times 3. We could call it 60 feet instead, if you'd rather. But I think we are good on this problem. So like I said, this is going to be a 2-part video. So we are done with the first part. Thank you for staying with me, and I'm sorry about some of the rambling that I did in this video. If you have questions, please make sure to email me. I know this one's a little more abstract and I was a little bit bouncing around in my thoughts. Thanks, students. Have a good day. We'll see you next time.